Composition over inheritance. Sounds fancy, right? But it's actually about something very simple, building things that don't fall apart when you change them. That's what we're solving today. Let's start with the definitions. Composition is the concept of defining a complex object by putting smaller objects together. Inheritance, on the other hand, is the mechanism of basing an object upon another to keep access and occasionally alter its properties and behaviors. So, why are we told to favor composition over inheritance? The most no-brainer answer is, in the long run, inheritance becomes a tangled mess that's just too hard to change, while composition gives you an overall smoother software lifecycle. Now, how can we apply this principle in Roblox? As you know, Lua is not a pure object-oriented language, so normally we'd have to import a framework or build our own to mimic common OOP tricks. But if you do that, what should have been just tables become elaborate ceremonies with ever-increasing cognitive complexity over time. This is where your tool stops serving you. All you need is a proper way of object construction and destruction. Thankfully, Entity Component System comes to our help. To explain it briefly, entities are your game objects, components are their abilities, and systems make those abilities work. Fundamentally, ECS applies the same principle on a different level. In ECS composition, components do not have to form something bigger. They usually store data of what the object can do, and systems decide when and how components should act. You configure your systems, you get a different behavior, and with different behavior you get a new game. So it's safe to say, ECS focuses on what things can do, not what they are. To build this in Roblox, we need a few simple things. We should be able to add, remove, and get a component of an entity whenever we want. When we add a component on server, all clients should know it, and when we add one on client, the server shouldn't know it. We should be able to define different components for server and client. An entity should have multiple components of different types, but only one of the same type. If you used collection service, some of these requirements might ring a bell. We will take advantage of collection service, so we won't have to implement a syncing system. Now the responsibilities of our ECS framework are reduced to implementing get component and being able to define both server and client components for the same type. Enough talk, let's get to coding. This should obviously be a module script in replicated storage. Based on the requirements, we will prepare the function signatures now. Let's create a sample component. As you see, our component is an object value which will point to a component script. It has three Boolean attributes, one to enable it and the others to specify its environment, client or server, and a string attribute for its type. Let's continue the implementation. Firstly, we need collection service and the environment. We will set up the functions that initialize the module. Moving on to the actual implementation now, we need to make sure the component is defined properly and enabled and finally in the correct environment. We should continue with registering the component. Now we will delegate the add and remove functionality to instance tagging signals of the collection service. We can start filling the functions. For each component, we need to create added and removed signals. reason we pass the entity as the parameter in both events is the component being actually a table and will be cloned in the events. The only reference to the real component is returned by the getComponent function. If you wish to add a timeout to the function getComponent, you can do it like this. Now let's name these magic numbers. As you see here, we are forcing component classes to have two functions, new and destroy. Remember what I said earlier, all we need is a proper way of object construction and destruction. So let's go ahead and define a sample component. This is the most basic way of defining a class. So yeah, every component is a class with two limitations. A function called new with the entity being the only parameter, and a function called destroy without parameters. You may add as many functions as you see fit, just make sure these two is always here. Now to make this work, remember why we chose object value and how we define its attributes. I'll set the component type to sample and the value to the class module. And I want this to be a server component. I'm gonna add a log here. Now I'm gonna insert a part and attach the component to it. We had delegated the component creation to collection service, so I'm just gonna tag the part. Remember, the tag is actually the component type. Of course, we have to require the module first. I'll insert two scripts for that, one for client, one for server. Now we can start testing. As you see in the output, the part indeed took a server-sided component. Now guess what happens if I check the client box too. See, now it has a client-sided component too. At this point, just go ahead and define components of your own, play with their attributes, figure out how the system works. That's pretty much it. It's really easy to implement and use. I know this looks like a complicated topic overall, but once you get the hang of it, I guarantee you'll never go back. I'll talk about systems in another video with detailed examples, so you'll see the true power of the ECS. And finally, thanks for watching. Have a nice day.